Okay, so let's talk about trig identities. So we need some formulas to prove trig identities. So there are a lot of formulas. So first, from the reciprocal identity, okay, we can find sine, cosine, and tangent. You flip them, you got secant, cosecant, and cotangent, right? Secant, cosecant, and cotangent. So quotient identities is the relation between sine, cosine, and the tangent, cotangent. So if you have sine over cosine, that's tangent. If you flip it, cosine over sine is cotangent. The harder one is the Pythagorean identities. Okay, so we have three Pythagorean identities. This is the most important one. Cosine squared plus sine squared is 1. So you can get the other two from the first one. Okay, from the first one. So the problem is there are so many identities. How can you remember them? So my idea is I use a special triangle to remember all these identities. I'm going to show you how, okay? Just remember this triangle, okay? Just remember this triangle. So first, so assume this is the angle X, okay? So I use X because in the lecture file, they use X for the angle in these identities, okay? Yeah. So now what's cosine X? The bottom side of the triangle, okay? Bottom leg of the triangle. And what's the vertical line? What the right leg of the triangle is sine X. And then what's the hypotenuse? 1. Okay, 1. So we just use this triangle to remember the trig identities. Okay, so first let's look at this quotient identity. Okay, so what's cosine? What's tangent X? Tangent X is opposite over adjacent of angle X, right? So you look at this triangle, what's opposite? Sine X. What's adjacent? Cosine X. So the definition of tangent based on this triangle give you this quotient identity. So similarly, you can get cotangent X is adjacent over opposite. So this is cosine X over sine X. Okay, so remember this triangle, then you don't need to remember two new quotient identities. Okay, and then the good news is this one. Okay, the best news is this one, right? So what's the Pythagorean theorem? Pythagorean theorem based on this triangle, right? This is set A, this is set B, this is hypotenuse C. So Pythagorean theorem is A squared P plus B squared is C squared. So now use this triangle. A is cosine X, so this is cosine X squared, plus B is sine X, so this is sine X squared. And C is 1, so 1 squared. Okay, so now simplify 1 squared, what do we get? Cosine X squared plus sine X squared is number 1. So you see, we get this Pythagorean identity based on the special triangle here. So this is a very important triangle. Okay, so you know the reciprocal identities, relations, and then you know this triangle, you know all the trig identities. Okay, you know all the trig identities. So why this sine squared plus cosine squared equals 1 is called Pythagorean identity? Because it is the Pythagorean theorem, Pythagorean identity for this special triangle. Okay, so let me repeat this triangle. So the angle is theta here. So this bottom is cosine, vertical side is sine, and the hypotenuse 1. Okay, so that's the triangle for identities. Okay, identities. So now let's try to prove the other two trig identities. So 1 plus tangent theta squared is secant squared. Okay, is secant squared. So how can we prove this trig identity? Okay, so we have two steps. Okay, two steps. Step 1, change to sine theta and cosine theta. Okay, so we have 6 trig functions. So first step, we change everything to sine cosine. Okay, we change everything to sine cosine. So 1 plus, so tangent, what is tangent? So let's look at left hand side. Okay, so LHS is for the left hand side. Okay. Tangent is sine over cosine. Okay, yeah, and then there's square, second power here. Okay, so for the trig function, we put second power between the function and the angle. So tangent squared, it means numerator squared, denominator squared. Okay, so this is left hand side. Okay, left hand side. So what's right hand side? Right hand side of the equation is secant squared, right? Secant squared, secant is 1 over cosine, reciprocal identity. So this is secant, and the secant squared is numerator squared, 1 squared 1, and then denominator squared. So let's write that one more step. So it's cosine squared theta. Okay, so second power of trig function, we put the number 2 between the function and the angle. That's a special way to write down the trig, second power of trig. Okay, second power of trig. So that's our step 1. We change left hand side and right hand side both to the sine and the cosine. Okay, so there's no tangent, no secant, cosecant, and cotangent. Only sine, cosine. Okay, only sine, cosine. So step 2, we will use the Pythagorean identity. Sine squared plus cosine squared is 1. Okay, so sometimes we don't need step 2. Step 2, we need this Pythagorean identity. Sine squared plus cosine squared is 1. Okay, is 1. So now let's look at this left hand side. Okay, so let's combine these two. 1 and the sine square over cosine square. So left hand side is 1 plus sine squared over cosine squared. So now we want common denominator. So we change 1 to cosine squared over cosine squared. Okay, so this is our number 1. Plus sine squared over cosine squared. Okay, yeah, so we just changed this number 1 to this part. So now we have common denominator. We can add numerators, right? So this is same denominator. Add numerators. Cosine squared plus sine squared. So what's numerator? The Pythagorean identity. Okay, the Pythagorean identity. So this is 1 over cosine squared. So now you look at this. We look at this. This is exactly what we got in the right hand side here. Okay, so this is the right hand side of the identity. Then we proved left is equal to right. That's the identity. Okay, that's the identity. So we have 2 steps. Okay, let's look at another example. So we want to verify cosecant x times tangent x is secant x. Okay, secant x. So this is an easier question. Okay, we only need step 1, and then we can solve it. So what's the step 1 of proving identity? Change everything to sine and cosine. Change to sine x and cosine x. Okay, cosine x. And we have 2 sides. This is the left hand side of the identity. This is the right hand side of that identity. So we need to prove they are equal after we change everything to sine and cosine. Okay, now let's first change left hand side. So I will use the purple color for left hand side. So left hand side is cosecant x times tangent x. So what's cosecant x? Cosecant is 1 over sine x. Right? What's tangent x? Tangent x is sine x over cosine x. And this is a multiplication, right? This is a multiplication. So now we can simplify a little bit because this is canceled. Numerator, denominator, cancel 1 sine x, pre-canceling, right? So left hand side, we got 1 on top, cosine x on the bottom. So this is left hand side. So now let's look at right hand side. Right hand side is only secant x. So what's secant x? 1 over cosine x. So now we got exactly the same expression for left hand side and right hand side. So we got left is equal to right. So done. Okay, it's proved. Left is right. They are both 1 over cosine x. So this is an easier question. We don't need the Pythagorean identity. Okay, so now next example. So we want to show sine x over 1 plus cosine x plus 1 plus cosine x over sine x is 2 and then cosecant x. Okay, cosecant x. So step 1, we change everything to sine cosine, right? So step 1, change to sine x and cosine x. So left hand side already only has sine and cosine. We only need to change right hand side. So right hand side is 2 cosecant x, so which is cosecant is 1 over sine, so it's 2 times 1 over sine x. Okay, 1 over sine x. So now we need to prove left hand side is also equal to this one. Okay, so now let's look at step 2. We may need this Pythagorean theorem. Sine squared plus cosine squared is 1. Okay, we may need this. So step 2, use this. Okay, use this. So now let's look at the left hand side. Simplify the left hand side. So this is sine x over 1 plus cosine x plus 1 plus cosine x over sine x. So they have different denominators, so we need common denominator. How can you make common denominator? First fraction times second denominator, so we have sine x over sine x. Okay, we use a number 1, change the numerator denominator here. And the other one, we already have sine, so we need 1 plus cosine. So this is 1 plus cosine x, 1 plus cosine x. So this is number 1. Okay, so we have a number 1, change numerator denominator. So now we have a common denominator, 1 plus cosine x times sine x. So what's the first one? Sine times sine, so we got sine squared. What's the second one? Second one, we got 1 plus cosine x times 1 plus cosine x. So this is squared. Okay, this is squared. So now use FOIL method, multiplication, we can expand this second power here, right? So what's the numerator we got? We got cosine squared plus, so this is cosine, so let's change the color for this expansion. So this is cosine x squared plus 2 cosine x plus 1. Okay, so that's the second power here. The blue part, okay, the blue part. So now we see the Pythagorean theorem in the numerator. This is the Pythagorean theorem. This is number 1, right? This is number 1. So now let's rewrite it. So this is 1 plus 2 cosine x plus 1 divided by 1 plus cosine x times sine x. So now 1 and 1 on top, you add them, you got 2 times 1 plus cosine x. So I replace this part by 1. That's the Pythagorean theorem, right? Pythagorean theorem. 1 plus cosine x times sine x. So now which one canceled? Which part can be canceled? These two, right? These two. They are both 1 plus cosine x. So now what do we have? We have 2 over sine x. So we simplified the left-hand side. We got 2 over sine x. So now we look at right-hand side. What's the right-hand side? 2 over cosine x. So this is equal to right-hand side. So left is equal to right. We proved the identity. So this question is not easy. We have 2 steps. Step 1, we change everything to sine cosine. And step 2, we use common denominator, whatever you can get, combine fractions, and then use Pythagorean identity. This is the Pythagorean identity. Sine squared plus cosine squared is 1. Okay? Yeah. So I will explain more in the quiz 4 practice problems. So the last part is the sum and the difference formula for sine and cosine. Okay, only for sine and cosine. So let's look at the formulas. Okay, so there are 4 formulas, 2 for sine and 2 for cosine, 2 for sine, 2 for cosine. Okay, so what's sum and difference? Sum and difference of angles. Okay, this is of angles, alpha and beta. Okay, so this is the sum inside the trig function. You have sum of the angle, difference of the angle, sum of the angle, difference of the angle. Okay, yeah. So what's cosine of the sum of the angle? You can use cosine of the first angle alpha times cosine of the second angle beta minus sine of angle alpha times sine of second angle beta. Okay, so cosine of the sum of the angle is this formula, the first formula, and then the cosine of the difference, sine of the sum, sine of the difference. Okay, so now let's use applications of these 4 formulas. Okay, so let's look at the first example. First example, we want to find sine of 5 pi over 12. Okay, 5 pi over 12. So if you don't know what's 5 pi over 12, you can change it to degree measure. Okay, so this is pi over 12 is 15, so 5 pi over 12 is 75 degree. Okay, so we want to find 75 degree. Okay, 75 degree. Okay, so how can we get 75? Okay, how can we get 75? So if you use reading measure, we have to split this to pi over 6 and pi over 4. So this is pi over 6 plus pi over 4. So if you use degree measure, it's easier, right? So what do we know? We know this is 30 plus 45. So we split 75 to these 2 angles, 30 and 45, because we have 2 right triangles. We know what sine and cosine of 30. We know what sine and cosine of 45. Okay, so now let's look at this sum formula. Okay, sum formula. So sine of 75 degree is sine of 30 plus 45. So this is the sum formula. So what's our alpha? Alpha here is 30. Beta is 45. Okay, it's 45. So now follow the formula. This is sine of alpha, so sine 30, cosine 45. This is sine alpha, cosine beta, plus cosine alpha, sine beta, so cosine 30 plus the times sine 45. Okay, yeah, so we don't know what's sine 75, but we know sine cosine 30, sine cosine 45, so we can use this formula to find sine 45. So now sine 75 is, what's sine 30? We need triangle, right? Triangle. So this is 30. So 1, radicals 3, and 2. So sine 30, 1 over 2. And then cosine 45. So this is radical 2, and 2, 45. So cosine 45, radical 2 over 2, plus cosine 30. So radical 3 over 2. This triangle again, right? Times sine 45. So radical 2 over 2. Then we have 4. This is radical 2, radical 6. Okay? So we know sine 75 is radical 2 plus radical 6 over 4. So we can find sum of the angle. Okay? Yeah. So now I will use same angle. Let's try to find cosine 15. Okay, cosine 15. So what's cosine 15? Cosine 15, so we still use 45 and 30. Okay, 45 and 30. So you see, 15 is 45 minus 30. Okay, yeah, so now we need the difference formula. Okay, the difference formula. So what's the difference formula? Cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Okay, so I already show you the full formulas in the beginning of this part. Okay, in the beginning of this part. So what's our alpha and beta? Alpha is 45, beta is 30. Okay, is 30. So cosine 15 is cosine 45 minus 30. So is alpha 45, cosine 45, cosine is 30, beta is 30, plus sine 45, sine 30. Okay, sine 30. So this is radical 2 over 2. So what's cosine 30? We need this again, right? 30. So radical 3 over 2. Sine that, radical 2 over 2. Sine 30, 1 over 2. So this is 4, 2 times 2. So this is radical 6 on top. Plus radical 1, the 1 times radical 2, radical 2. Okay, radical 2. So cosine 15 is radical 6 plus radical 2 over 4. Okay, so if you did pay attention, this is the same as sine 75. Okay, sine 75. So now let's prove it. Okay, sine 75 and cosine 15, they are equal. But we will prove a more general formula. So from our calculation, we already see they are equal. That's our two previous example. Okay, so now let's prove a general formula here. So we want to prove cosine x minus, so pi over 2, 90 degree minus x is sine x. So if x is 15, we got the purple equation up there. Okay, this is 15, this is, sorry, if x is 75, so this is 15. So this is 15 if x is 75, and then this is sine 75. Okay, so again we need the difference formula for cosine, right? So cosine pi over 2 minus x, so this is cosine pi over 2 times cosine x minus sine plus sine pi over 2 times sine x. Okay, sine x. So now the problem is, what's cosine pi over 2? What's sine pi over 2? Cosine pi over 2 is 0, right? So where's pi over 2? So we look at this point. Pi over 2, this is the angle. Pi over 2 right angle, right? So this point is 0, 1. So x is 0, y is 1, r is 1. X is 0, y is 1, r is 1. So cosine is x over r, so this is 0, right? 0 times cosine x plus y over r is sine, so it's 1 times sine x. So this is sine x. Okay, this is the sine x. So we can also use sum and difference formula to prove the relations between sine and cosine. Okay, prove the relation between sine and cosine. So that's the last part of the trig and the last part of the math 30. Okay, math 30.